Welcome to today's lecture, the first one of the week. We'll be talking about static and dynamic testing. So I'm just going to share my screen so we could at least be looking at the contents for today. Now, before we start, we're going to have a brief warm-up exercise with some Zoom polls. So you will be able to kind of remind yourselves about some concepts that you have previously learned, and also kind of get engaged into today's lecture. And yeah, so Jumana, you can put the poll up. You will see about 8 options, and then from each you will have to select based on the option, right? Which is the correct one. So for example, you have reviewing test cases for black box testing of a login module before execution. And you have, is that static or dynamic testing? So do this based on your opinion. So there are no rights or wrongs. You have already been introduced to some dynamic testing, types of dynamic testing. So that maybe will be some support to you when answering these polls. So without further ado, you can go ahead and choose between the 2 options for the 8 sections that we have for this brief exercise. And don't worry, there is no right or wrong. It's just trying to see how we're all thinking differently, and then we'll do a brief debrief of everything that we discussed. So go ahead.
You should all be seeing it right now on your screen.
Yeah, so there are 8 sections, 2 options for each, the same options. Try to kind of remember what you were learning in the previous materials. All of the examples are taken based on things that we've more or less discussed. Okay, already see some answers coming in. All right. I see the answers are still coming through. I'll wait for a few more minutes before we go through all of them together. And don't worry, it's even better if there are different answers for both, so both options are selected. That way we can also maybe see why we're thinking in that direction, so it's not an issue. And also keep in mind, if everybody selects the option, it doesn't mean that it's the correct one. So don't try to think a bit based on the scenario. Don't just try to see if somebody's selecting it, then it's the right choice. Oops. I see about 10 answers for each for now. Wait a few minutes if somebody else wants to populate. I see in the live chat, Daniel, that you've answered A. If that's not maybe a typo, you can use the poll to select the options. So for the answer that you wish to give for the question. So we don't need to use the live chat right now. Okay. All right. I think we are on 10 people each for now. So give 1 more minute, so we round up to about 5 minutes, and then I'll go through each option together and see what is the correct answer. Okay. All right, then let's go briefly through all of these examples together. So the first one that we shared in the example, reviewing test cases for black box testing of a login module before execution. So a keyword here is reviewing. So we're not actually going through the tests themselves. We're not actually executing something. We're just going through the test cases. So we're just reading through something, meaning that it's not something that we're doing dynamically. We're not checking a component or something. We're just checking whether some kind of documentation is correct. Therefore, the correct answer here is static testing and not dynamic. So dynamic is more or less the testing execution that you do after an application works. So this is the idea of dynamic testing. You cannot see the poll. Sorry. Okay, let me check. Uh, do I need to end the poll for it to be visible to everyone?
I don't think it will be visible, but we can test it out.
Okay. Let me just see. I'm gonna try something. Just a moment.
Oh,
I think it should be
yep.
visible now, right? Okay, great. Thank you. All right, fantastic. Thanks for the heads up, everyone. Yeah, so the first one, as I mentioned, reviewing test cases for black box testing. So we know that black box testing is a type of execution of the test cases after an application works. However, the keyword here is reviewing. So when we are not actually doing anything outside uh, connected to the app's execution, so we're not doing it after the software is executed, we're doing static testing. So even though we have black box mentioned here, we need to focus on the bit reviewing test cases. That is the action. Oh, okay. So it went away. I see. Uh, I think I haven't closed it.
I can provide screenshots as you go along.
Okay. Okay. Fantastic. Thanks.
Okay.
Yeah. Then moving to the second bit, we have inspecting unit test code to ensure it follows coding standards without running it. I see most of you again wrote down static testing, which is the correct answer. And again, we have inspecting. So keep these keywords in mind when we move on into the lecture because you will come across them a lot in these materials. So it's inspecting. Again, we are not executing the code. We're just going through it, making sure that everything is all right there. So we don't have any application running. It's just us going through some kind of inspection of the components that would be tested later on. That's why here it's static testing once again. Then we move on to executing gray box functional tests on an e-commerce checkout page, which is dynamic. Most of you got this right. This is after the application is finished. So this is something that we can do dynamically. We check it ourselves. We perform the steps, meaning that this is dynamic. If we move forward, we will have analyzing system requirements for an upcoming integration testing cycle, find ambiguities, analyzing, again, another keyword. So we're just going through the requirements. We take the data that we need for some kind of integration testing that's to come. So this is, again, static. We're not interacting with the application in any way whatsoever. You can already see some kind of difference between both static and dynamic testing. So it will become more clear when we tackle the materials moving on. Then we have running unit tests for our payment API to verify each method works as expected. So we have running here. So we know that we are the ones executing this. We have to have the application running, meaning it's dynamic once again. So again, we're performing something after the app works. Then we have one with everybody who agreed on dynamic, which is performing integration testing between the payment gateway and the order management system, which is excellent. Integration testing was one of the levels of testing, and it's a dynamic testing type. So you're checking how the components interact with one another. So great job for catching onto this. And it's definitely not static. So we do go through components and their connection in between. And then moving to the last two, we have peer reviewing UML diagrams for correct component interactions before integration. I can see why this is confusing and some of you added it as dynamic testing. We again have integration testing. However, again, peer reviewing, we have review. So we're not actually doing something directly to the application. We're actually going through something that's related to it, making sure that before it goes live or before it's deployed, we are following some structure. So again, this is static. So we're just going through the documentation. We're not actually working on the application. But again, I can understand the confusion here. Again, it's related to integration testing, and obviously that is dynamic, as we mentioned. And finally, conducting user acceptance testing to verify the mobile banking app's client requirements are met. Most of you here added static dynamic testing and then a bit for static testing. Again, a good mixture here, but acceptance testing is a type of dynamic testing. So you try to do user interactions, which can't be done unless you already have the running application. Again, keep in mind the order of when I'm differentiating between the two testing types. So this already needs to be up and running. You need to perform realistic functional scenarios that the user would do, meaning that this does fall in the category of dynamic testing. So I think that is more or less everything from the poll. And thank you all for taking part in it first and foremost. So hopefully you kind of got the opportunity to also remind yourself about some of the testing concepts like black box testing, gray box integration. Keep them in mind. We will mention them during the lecture as well. So do you have any questions regarding the exercise? Do you have any something that piqued your interest or something that you maybe think is otherwise related to the answers? I don't see for now anything. All right, so I'm gonna stop sharing the poll here. Even if it's not visible, I think I need to do this. I'm just gonna close that. Right, so we just went through this exercise, saw some differences, some key terms that differentiate between actual static and dynamic testing. And we've already, as I mentioned, been introduced to some dynamic testing types. Now, while dynamic testing in itself is the most common type of testing that you do perform as a QA, it's very important to highlight how important it is to have static testing. Now, here we have an interesting example where we have a social media app development team that made some kind of AI-assisted test automation product, and it quickly generates a lot of scenarios and then executes them. But we run into the issues that the tests have a high failure rate. And some of those, or most of those actually, are false negatives. So the test scripts are the issue, as we mentioned previously. So they do test dynamically things, but actually have they done any preparation beforehand? So has there been any review of the actual scripts? Has somebody gone in depth to see whether the scripts are relevant, whether they have good coverage, whether they actually test what needs to be tested for the components, integration, so on and so forth? Has anyone done a review of the requirements? So when you take into considerations all of these aspects, you understand that when you perform testing, it's not only about covering the functionalities and then you're done, everything is okay. It's actually starting as soon as possible and performing tasks that are not really related to the application's execution. Hence, static testing. So to keep it simpler, we will define them both, static and dynamic testing, in the next slide. Static testing is something that you would want to practice as early as possible within a development lifecycle because it does provide a lot of time. It does provide a lot of cost benefits because you start as soon as possible, and you definitely, in a way, um, take the time and effort that you would need without it down a lot in comparison to when you would completely ignore it. So the idea for today will be to be, as an outcome actually of today, would be to be able to analyze various types of static testing and how they ensure the execution of meaningful and well-designed tests. Explain the various phases of a formal review in static testing. We'll go through this. Some of you may have even at one point heard about these types of reviews. To understand the difference between static testing and analysis, which is very important, and list tools routinely used for static analysis. And of course, describe which static testing processes are used to prepare for specific dynamic testing strategies. So we will see at the end that these two kind of correlate with one another in a way. So it doesn't mean one kind of erases the need for the other or the other way around, but actually how does one complement the other and how can we make use of them? Okay. So what is meant by static and dynamic testing? So to put it simply, how you can differentiate these two types of testing. Static testing is the testing that you do that is more related to analyzing documents, requirements, specifications, architecture of a product. So it is static. It's called static because you're not actually trying to perform any activities on the application itself. So you're trying to read through documents, code, so any type of documentation related to the product, and that's where it actually gets its name. Whereas dynamic testing relates to the testing that you do upon the application's execution. You already know some of the types of testing and levels of testing we discussed, like unit, integration testing, system testing. So all of those types of testing fall under dynamic because you're actually interacting with the application itself. So to put simply, before application is executed, it's static testing. After its execution, it's dynamic. It's important to note that static can still at some points be performed when the app is executing. If you would like to, for example, go through some additional requirements, or you might have noticed some kind of issue within the documentation that you did not caught early on. However, the practice is before execution static and after dynamic testing. I see a question. I didn't miss any lessons, but I've never learned static versus dynamic testing. I don't know why we have that test. I know nothing, in fact. No, the idea of it was not to, the idea of the exercise was not to test your knowledge for static versus dynamic testing. The idea was to use some of the previous things that we already went through, so like black box, gray box integration testing, and see if you have any idea of what these terms would mean. So it's not to evaluate or to see how much you have prior knowledge. It's actually to kind of get you into the entire material and just get an idea of what's how these two concepts actually work, and then we kind of move into the lecture. So yeah, so no need to learn about the lecture itself beforehand to get it. Okay, now moving on. No worries. Okay, so static testing, what can be reviewed? So when we talk about static testing, one keyword that I mentioned earlier is reviewing. And reviews are basically a synonym for static testing. And the things that I mentioned previously when providing the definition include requirement and user stories. So you can always go through the requirements before anything is developed. Design documents and models. So these design documents and model relate to some kind of architecture, infrastructure of the software, some diagrams. So you can definitely go through these and see if maybe there are some missing links, some requirements that may not have been tackled, which is a very efficient way of doing static testing. Source code. If you are versed in understanding code or development code, actually, you could go through the source code, and even if it's maybe not the highest level of development, you can still see where there are some missing lines, maybe misused variables, methods, so on and so forth. So you can do that. Test plans, test cases, test charters. These are the most important because those are the ones that come from our side as testers. So reviewing them is key. Contracts and project documentation and product backlog items. So again, if you're working with something that is more related to researching about legislative or regulatory laws, you would definitely need to do an in-depth review of how the contract is defined and to see if there are maybe any, let's say, areas that have not been fully covered since the application relies on it. And product backlog items are more related to test management softwares where you would have additional stories that might help you at the current sprint or in another work iteration. So that is the idea behind static testing. You review before you actually start working. So as you may see that these, let me see, analyzing, reviewing, documenting, inspecting are some of the keywords. Yeah, exactly. Those are that's the general idea. So these, when you put them together, kind of make up the entirety of static testing. So well said, Susan. Now, what are the benefits? When you do static testing, as I mentioned earlier, you start as soon as possible in the software development lifecycle. So because you're not very dependent of whether the application is working or it's executed at the moment, that means that you can start at the very beginning. So you can start at the planning phase of the entire project. And what this brings to the table is early detection of defects. So you can find issues, believe it or not, even before you start developing what has been done in the entire design of the application. So This could be some maybe missed requirements. It could be something that maybe even the stakeholders have missed from a user's perspective. So that's how this comes in handy. And in the bigger picture, this doing so will lower overall cost and also require less rework and save on time. So if you find these issues beforehand, they will be worked upon before the code is deployed, and you won't have to try to find the root cause moving forward. It improves communication and understanding among stakeholders and amongst yourselves, so you get a clearer picture of what needs to be delivered, and then increased confidence in the quality and completeness of work products. I can add one benefit. A while ago, when I was introduced to a new project, we had a very long time to wait for an onboarding, and we were basically, how would I say, uh, rendered incapable of working through the in-depth documentations that we needed to do. And what we did as a testing team is we took the base, the one documentation that we provided, and we made sure to cover all scenarios that we could with test cases. We had a meeting together with the infrastructure or the infrastructure and development team. We'll see the name of this review later on. And we basically went through test cases, and it actually very much supported and helped the developers and the architecture team in their logic. So they saw that they have plenty of flaws because previously they did not take them into consideration. So this included edge cases and negative scenarios that they might have missed because this is a large amount of work. And then they also gave us input on what we could additionally cover from their experience. So this is the general idea of how to practice the static testing and take the most of its benefits. Some common defects that you may come across is ambiguous or missing requirements, poor module design or inefficient architecture, undeclared or unused variables, code that doesn't follow standards. So these are pretty much things that you can find in any document, source code, architecture. The most common ones usually being missing requirements. This is pretty much what you will be seeing 90% of the time when doing static testing. And then undeclared or unused variables. It's very easy to come across these, even methods that are just existing for the sake of it. So these are the general issues that you could detect with it that you might miss with dynamic testing. Now, comparing both to one another, what are the differences? So we stated one is done without executing, one is done with executing code. So dynamic is post-execution, static prior. Static testing finds defects directly, and dynamic testing detects failures, which are then analyzed. What is meant by this? Well, in static testing, you find the issue, you discuss it, and it's avoided immediately. So you're not actually doing any tracking of the root cause. You don't need to go into detail of what happened, trying to recreate each step as you would do with dynamic testing. So this definitely saves a lot on time. The difference we mentioned already for the executable and non-executable items. Useful for early reviews, code inspection, and useful for runtime behavior, performance, and output. So static testing we mentioned goes into reviews, inspections, walkthroughs, while dynamic testing needs to showcase how the runtime of the application is and what is the performance of the software itself, as well as the output. Is it what we are expecting? Then we have finding defects in logic, structure, standards for static testing, and defects in function, integration, or flow. So again, we're trying to come across something that is basically documented as something that is in the design phases of the application. So that's why this is more related to static. And then find defects in function, integration. These are the types of tests that we have already mentioned that are dynamic. Finally, one of the key aspects, static testing helps assess maintainability completeness, meaning um, how is the application overall? So is everything covered? Do we have everything that we expect to be an output noted? Do we have everything that the users would expect, the stakeholders? So we make sure everything is complete and maintainable. Whereas with the dynamic, we assess whether it's usable. So can the users expect to get a fast response when they interact with the application? Is the application running at a way that the processor and memory of our instances is not used up? So functional aspects that can be tested with the application running. Now, before we move on, do you have any questions? I see Stephen wrote, undeclared variables as offline static testing suggest using automation to check it. Is that not dynamic, or will tester manage checking the code? Well, the thing with the undeclared variables is that when you're doing dynamic testing, you're not actually inspecting the code of the developer. You're just going through the page or calling an API, whatever it may be, depending on the automation testing. So you do not really go into their code to see whether they have um, some undeclared variables, let's say, or empty methods. That's why it's part of static testing, because you can do it. You can go into the code and you can just do a brief review. And yeah, it's done manually. So and we will talk about the automatic way of this, but that will be further down the lecture. We'll also mention that. But this is part of static testing because it's done prior to execution. So with automation testing, you won't be able to see it. Any other questions? Okay. If not, we have a small exercise here. So you will notice that we have here, let me just scroll down a bit. I see one more question from Valentina. Are testers divided in teams, static dynamic testing normally, or will they, for the same project, flow from dynamic testing? You actually have to do both. So this is a practice that all testers follow. The idea is that you need to be engaged in both because static testing is not only practiced by one person. So in one way, you will perform it on every project, whether that be writing test cases and going through requirements or doing the test plan from the very beginning. So static testing is always involved. You can't really you can't really avoid it, and it's an integral part. Yes, for the same project as well. So just doing plain example, just writing test cases static testing, and that's like 90 and 100% of projects. And then you need to execute them manually automated. That's the dynamic bit. So you will definitely use both. Okay. If no other questions, wonderful. Let's do a brief exercise. So we have a few activities. You need to let me know which of the following activities might be appropriate to apply static testing techniques to. You can you can select as much as you want, so it's not limited to one. And yeah, you can write them A to Z, 1 to, how many options we have? 1, 2, 3, 7, 1 to 7. So I'll give you a minute to go through them. Okay, I see. Let's wrote all the options, all. Okay. Interesting way of thinking. Let's see. All right, I see more answers coming through. I'll wait for a few seconds because I can see people are typing. So 1 to 7, fair enough. Okay, all of them. Okay, so let me just briefly select all of them because I saw the multitude of answers was related to all of them. And we're going to check. And you are correct. Yeah, that is all of them. So everything that we have here can be passed with static testing. And that's a great way of thinking because if it's stated like, let's say, automated test scripts or developer code, it still could be statically tested at one point. So very good job, everyone. Okay, now we're going to move on to manual static testing techniques. Review types. So we mentioned in the previous section that reviews are synonymous with static testing. So the idea of a review is that you basically take some kind of documentation. It can be an application, test cases, user stories, so it could be anything, and you basically go together through it with at least one more person. And the idea here is that you detect some kind of errors, some kind of anomalies early on, with the drawback being that you would need to organize the people and take a bit more time in earlier phases so that this can be conducted. Now, there are multiple types of reviews, and we will briefly go through all of them. One of them is inspections. So this is a formal process. Basically, there is a reviewer. It most often than not is an external person. And the idea is that I see a question, can there be automated static testing? I can answer that with yes, but we will save that for a later section, which we'll discuss about that bit. So inspections are more or less checks of whether the code and documentation make sense by an external party. Then we have walkthroughs, which are less formal. And here it's usually a process between developers, software testers. It could also be product owners. It could be Scrum masters. So basically, it could be a multitude of roles here where feedback is sought early in the design phase. One such example is a meeting that I highly encourage any tester to have, which is Three Amigos, where you take test cases that you've designed based on requirements, you review them with the developer and the product owner, and then afterwards you get input so that you can maybe enrich or take out some of the test cases, and they get the information of if they have missed some requirement for the product owner, or if the developers are missing some unit tests or scenarios that they have not covered. So walkthroughs are one of the most commons you will come across and are very, very helpful. Technical reviews done by a technical specialist. It could be the developer, it could also be the tester. And the idea is to find as much issues in a more informal manner, let's say. So the review is done, usually is done also in front of the clients before everything is finished and ready to be deployed. And the idea is they could see if maybe they want to change some requirements. So it doesn't necessarily have to be an issue like a bug. It could be an additional requirement for the bit being reviewed. Then we have audits, formal reviews that make sure that standards and regulations are met, so compliance standards and regulations are met. These ones are usually done by auditors, so this is not really directly somebody within the team that does it, but still part of these. Then we have peer reviews. You might have heard of these where a colleague checks one's work. So this is mostly done with programming. It's known as peer programming. So one of the two people involved does the work, the other supports or just gives an overall review of what is currently being done. Then we have informal reviews that are similar to peer reviews, but more casual, as is stated here. So you have multiple team members that kind of do an ad hoc meeting and just see and go through, skim through the code or documentation. Most often these are done when there is a big change that's been requested, or essentially when you're trying to meet a deadline and you basically need to have more, let's say, than just the stand-up during the day. Finally, formal reviews, a less frequent but very structured review process. This is a common practice to have this at least in Scrum methodology once every sprint. So we'll have this type of review. It's less present in different types of methodologies. However, the idea behind it is that it's comprised of multiple phases. All of them are followed, and it's a way of showcasing what has been done and what are the next steps moving forward. Now, as with any review, we have different roles within it. And why is it done so? Is that so the process could move smoothly, so that there is somebody who is handling the moderation, somebody who is presenting. So the idea is to have a clear and concise um, structure of the overall review. Now, for the roles, we have manager. So the manager is somebody that decides what will be reviewed. They give the resources. This includes people, time, tools, so on and so forth. And they make sure that the review aligns with project goals. So they make sure that whatever is discussed will be within the scope and it's towards the end goal. It's not just something that needs to take place. Then we have the author. You can also remember it if it's easier, like developer tester. So this is the person who creates the work product being reviewed. Why do I say also tester? You could be reviewing some of the test cases to the client. So this is still your work product. So it's not only the application itself. The idea is that this author clarifies content, answers questions during the review, and then afterwards, if there were some issues that were identified, they would need to correct them. Then we have moderator. This is the person who leads the review and makes sure that everything runs smoothly. So guides the meeting, manages time and participation, and creates a safe and respectful environment. You already, most of you at least know how the moderator functions. It does the same as within any review. Then we have the scribe or the recorder who records all important review information. So any anomalies, defects that may have been detected during the review, any decisions made, so any as I mentioned, new issues discovered. So anything that is of high importance is recorded. And usually this is done in a method using minutes of meeting. So everything is noted down within that discussion is shared in the chat, then separately through mail. So that is the idea of what the recorder does. Then we have the reviewer who goes through the work product and gives the feedback. This can be anybody. It could be a stakeholder, it could be team members, it could be some expert from that field. So it could be some consultant that needs to go through the documentation where they need to support. So this could be tackled by anyone. And finally, we have review leader who takes the responsibility of organizing the review. And the review leader and manager sometimes go hand in hand because as you can see here, they also select the team who reviews, schedule the review, and ensure all participants are prepared and have access to the work product. So it's worth noting that although there are multiple different types of roles, it doesn't mean that a single person gets one role. For example, a scrum master who is like a leader, let's say a manager of a development team, could be the review leader, the manager, and the moderator at some point. So it's not tied to just one single role that is done by one position. So the tester does the, let's say, moderation. It's not tied to that. Sometimes even the tech lead or a developer could be the review leader as well as the architect and the moderator. So these are all interchangeable between the roles in the team. Now we see a question from Binu. I have a question. Who's involved in formal reviews? That's a wonderful question. Usually formal reviews are structured in this way. You take the entire team. So that includes developer, QA, DevOps, if present, proxy product owner, then you have the scrum master, so everybody on this side, on the development side, and then representatives from the client side. So it doesn't necessarily mean that every representative on the client side is present. However, usually 2 to 3 people who are more involved in the project are taken in as part of the formal review. So the idea is somebody from the client side and the entirety of the development team. This is for most cases. There are even instances when only management discusses this with the clients, but more often than not, the entire team. Right? Do you have any other questions? No, no worries. Okay. If there are no additional questions for this, we will move on to the formal review phases. Now, we mentioned that the formal review in itself is a more complex process than the other reviews. And the idea is that this follows a, let's call it a structured process defined by ISO IEC 20246, and it can be modified depending on the size of the work product or the formality required. This is like a standard. There are multiple things that are standardized by this, how would I call it? Uh, let's say organization. So this doesn't need to be learned by heart. Now, the phases of the formal review are presented here in this diagram. So we can see them all in this in a way hexagon. We have planning, kickoff, preparation, review meeting, rework, follow-up. It's a pretty standard flow of how review goes. However, when you take them into consideration, they're very much of help when having these formal reviews. And why is that? Well, each phase of this review is followed at a certain bit of the development lifecycle. For example, first is the planning phase. So first there is a proposal, so this review can be held. And the idea is that those who need to attend are given their invites as well as the date, time when the formal review will take place. And also there is the part of providing everyone with the documentation and materials that need to be reviewed. Then we have an optional phase, which is kickoff or review initiation. And this is essentially to see whether everybody understands what is going to be reviewed during the formal review. So if somebody has maybe some questions, if somebody is not very familiar or new to the project, they usually take this opportunity using smaller meetings or even just email messages or chatting. Any way is okay for this scenario to get more familiar with what they need to be reviewing. Then we come to the preparation or individual review, where everybody in isolation does their own review of the product, which greatly helps in the overall review because everyone will have a very deep understanding and have some kind of input in the overall process. Then we have the review meeting, and this one is divided into three sections. We have logging and analysis. So everything and everyone that has found as an anomaly. So just a disclaimer, anomaly does not necessarily mean bug or defect. It's sometimes even a missed requirement or something that might have come across as a misunderstanding. So it doesn't necessarily mean that it's something that's a bug. And then each of those are tackled, and based on their priority, they will be classified as high, medium, low, critical, major, minor, depending on that. Then there's the discussion phase. So this one is used to decide the status, owner, and action required based on what what was logged during the meeting. So if something is a defect, should it be tackled immediately? If it's a missed requirement, how important is that missed requirement? Should it be allocated immediately? Should it be set in a backlog? So this is the idea of the discussion phase, and then the decision, and where the team essentially decides whether everything is met, so all the requirements are met, and if there are any exit criteria. So we know what we need to complete in order to say that the project has completeness after these criteria are fulfilled. So that is the decision phase. Now, after we have finished the review, we have two more phases. We have rework. So this is the phase where everything that was discussed and assigned is worked on. So essentially, if there were some missing requirements, they're added to the documentation. If some components maybe that were worked on did not meet client requirements or were actually influenced by some issues, are fixed. And then the idea of the rework is to make sure that everything that was in a way an anomaly is mitigated. Then we have the follow-up, where everybody provides as evidence what they have finished, that everything is working as expected. And then the moderator, the manager, collects feedback and documents. And then everything that has been done is saved for future reference. So what can be improved, what was good, what was exceptional, and what needs to be taken as an action item for upcoming work. So this is basically the idea of the formal review in itself. And the point of these reviews is not to, the idea of these reviews is not to have them very often. So you won't have formal reviews on, let's say, 3 days basis or a weekly basis. This is something that occurs at the end of a milestone or when you essentially finish the work for a given sprint, let's say 2 weeks. And the idea is to have a more structured way of everyone knowing what's going to be presented, and then how everyone should prepare during the meeting, what should be analyzed, what should be tackled, what is the focus, and after that is done, what needs to be reworked, what needs to be provided as completed after that, and of course, what can be learned as a lesson from that entire process of development, of the review, and everything that was provided. Do you have any questions for this section? Okay. I see a question, or like after a regression testing. Um, I'm sorry, Bino. What correctly are you referring to? It's like, is the formal review after a regression testing, or let's see. Mhm. Uh, well, mm, there could be a formal review done in that case, yes, but the more what these formal reviews refer to more is actually to um, milestones in a way that, for example, let me put it simply, your project milestone that you're working in the next 2 weeks is to take a banking applications payment system and implement it on the website as well. So you're not only using it on mobile, you want to add it on a website, and you have 3 weeks. So the idea is you schedule in 3 weeks this formal review where you will go after what has been developed, what has been tested, what are the results, what are some things that you might have noticed that some of the stakeholders have missed. And the idea is take all of these into consideration and have a formal meeting regarding them. So it's more of like related to every aspect of development, not only testing. Makes sense. Okay, wonderful. No worries. I'll move on then to the exercise, and if there are other questions, we'll go through them after it. So we have one short question here. Which most accurately describes the difference between the kickoff and preparation stages in a formal review? So you have 4 answers. You can write A to D, or you can write 1 to 4 in the live chat. Which one of these four do you think is the correct one? So difference between kickoff and preparation stage in a formal review. Okay, I see Susan give us a very detailed answer for this. All right, wonderful. It's great. We have 3 answers for the first option. Wonderful. Keep them coming. Right. I'll wait a few more seconds. Move on. Okay. All right. Great. So I see everybody is writing A, and I'm going to confirm with you that this is the correct answer. And yes, you might have noticed that it's optional. So this is the keyword we're looking at for here. That is correct. So a wonderful job for that. I see a question from Valentina. Is there a legislation that makes all these meetings, reviews, types of testing mandatory in some companies, such as ISO for other purposes? Well, it definitely, it's not like, I would say, um, there could be, I'm not sure for this. This could also be research if there are companies that enforce, let's say in a way, or make it mandatory that these meetings are present. Maybe if a company has a household product, something that they make, and then they want to organize everything and keep it into check, maybe in that case they have it like that. But most companies, especially those with outsourcing or the bigger ones, like let's say Google, Amazon, Microsoft, they usually have separate teams working on separate projects, and this depends on the team. You can also go into a team where you would have only one meeting during the day, like a stand-up, so you won't have any types of reviews, which is not a good practice in any way. So this should be avoided and have some kind of implementation within the entire process so that it could be better. However, I would say it's based on the company. Okay. Yeah, most of the time, no. As I mentioned, take this with a grain of salt. It could be that some companies do it, but I'm not very sure because I've not really worked with something that has like their own project. So yeah. Oh, no worries. All right, then I'll move to the next part, which is reviews in practice. Now, as we saw earlier, formal reviews are a bit more complex, a bit more structured, take a bit more time. And the idea of them is that you do not do them so frequently. On the other hand, there are reviews that you could do quite often, and we will see some of them here. The main idea of them is to find bugs earlier, maintain compliance, enhance security, share knowledge. So there's there's a vast amount of these types of reviews, and some of them include pair programming. So we already talked about this peer review type, where two developers or QAs, it could be also mixed. It doesn't really, this doesn't really mean only specifically developers do it. One is doing coding, the other is sharing the screen, and the idea is that they can switch back and forth. So they're actually working together to produce some kind of result. And the good thing here is that you can transfer knowledge, and also it's really, really helpful when you're running low on time and you need to complete a more complex task where somebody has a lot more experience, but it's assigned to the other. However, it is time consuming and difficult to track work amount. So you don't really have how to track the amount provided since it's two people. It might take 3 hours, but you really never know how complex the task was, especially if maybe that would have been done by a single person in an hour and a half. So the idea is it takes a bit more time than it's needed most of the time, but nevertheless, it's a good practice to share knowledge. Over-the-shoulder reviews. This is pair programming. However, the difference here is that you are not essentially working together to get the code, but you're actually you're more focused on just reviewing everything while it's being done. So it's easier than pair programming since it's not multiple opinions coming in together, but it's again difficult to track again since it's two people's time, so you can't really make a calculation on it. Email pass around. So this could be done to email code management systems. It's again related more to just reviewing something that the person has done. The only thing with this is that you don't really get the feedback, constructive feedback from the person in a whole. You most often get pointers this way, and it could be sometimes confusing since you would need to maybe get more details from the person, or if let's say a code review, you would need to ask specifically maybe what line are they referring to exactly. So that's some of the negative sides of that. Tool assisted reviews. So somebody mentioned previously, can we automate static testing? So technically we can. So this uses static analysis tools, which static analysis in a way is part of static testing. And the idea is to use these tools to make a review of the code, and it can be actually done by the person themselves. So it's actually very costly, but it kind of supports tracking metrics in a more simplified way, and also supports the idea of saving on time because it's something that you don't really necessarily have to incorporate multiple people to review something to get whether the results provided are accurate. Other reviews could include, as I mentioned earlier, the Three Amigos, which is also a type of informal walkthrough where you go through your test cases and essentially just show everyone what you have designed. This can be something that's implemented every sprint or every week or two. We have refinement meetings where product owner shows user stories to the developers and testers. They come up with ideas for something that might be missing. So there are multitudes of these that you will come across when working on a real-time project. Any questions so far? Okay, I'll take it as a no. We will not do this exercise for now. It takes a bit more time to read through and everything. So we will move to test data management. Now, obviously when testing, data is very important. So when you execute tests, you would have to have accurate, you would have to have relevant data, not just try to use anything for the sake for testing something. So the good thing is that you can actually validate data using static testing. And the way that this is done is actually through multiple different processes, which we'll see now. So when you're testing, you want to have relevant input values, conditions, scenarios for verifying and validating functionalities. You want to have some relevant usernames, passwords. So you want to have all of these bundled and ready for testing. Now, what you can do with static testing is you can actually make sure that the criterion for this test data is met. So do you have valid testing accounts? Most often than not, this is an issue if preparation is not done ahead of time. So generating them via an SQL or depending on the system that you're using, these valid credentials and invalid credential is essential, and it is part of static testing because you're essentially just preparing this test data that you're going to be using later. In addition to that, often there is the scenario where you do not have enough data, so you might run off due to multiple, let's say, smoke or regression runs. So making sure ahead of time that you generate a vast amount of data is also key. So the data that you're using for testing essentially can be prepared in a very high quality if you perform static testing principles. Now, when you're working with test data that you want to use in your dynamic testing, there are two aspects that you need to consider. So the quality and the quantity. Regarding the quality, we already mentioned some of the key aspects of it. One is relevance. So it's not only about generating data that fits the test. It actually has to be something that's relevant. So something that you can see in the real world. So if you're using some kind of email, you definitely want to add maybe Hotmail, Gmail, something at the end, not just add test and then see what happens. Then diversity. So you want to have different sets of inputs. You do not only want to be focused on the same input all the time. This creates exhaustive tests, and these are tests that deprecate over time, meaning you've used the same data so much and you always get the same result that you don't really have any coverage due to the lack of diversity in the input and output. Then we have manageability. So it should be easy to maintain and it should be regularly updated. So you don't want to include data that's hard to maintain from an aspect, let's say again, the credentials. You do not really want to, let's say, implement credentials with super lengthy names that might be even difficult to find when you're doing automation testing because simply you cannot read the output of the app's execution due to the very long name of the data. And also, um, this data should also be updated regularly. So if you're, let's say, working with regression, with automated regression tests, the practice is that after every run, you would update credentials. So you don't want to use the same credentials over and again. So you want to add new ones because who knows, maybe something new will pop up. Finally, consistency. So the results need to be spread. So the results have to be made sure that they are sporadic and difficult to ascertain. So you don't want to use data with which you will bring about confusion to both yourself and then to even stakeholders or developers alike. You want to use something that when you get the results, you will have an idea of why and what something has happened. Now, going hand in hand with this is the quantity of data. The idea of quantity is that at all times you would want to have as much data as possible. And when you generate data during dynamic testing, this could become a hassle because you're testing at the same time and then using a different tool to generate additional data. And then you use both time in the testing and in the generation of data. So doing this ahead of time is key. And one way to think about it is to try and see what kind of tests you're going to be using the data for. So are you going to use it for regression testing, smoke testing, just testing a specific component? Having in mind what kind of tests you want to perform will help you prepare the data ahead of time. Because let's say you're doing something with regression testing, and then you also need data for a component. If you only prepare a certain amount for the regression testing, chances are that this data will be used in its entirety because you run a lot of scenarios. So it could happen that all of the credentials that you've used are over and done with the regression itself. And now you need to go back, generate some other credentials for the component testing. So the idea is you prepare ahead of time and you can do a multitude of things to prepare this. So you can do some SQL queries to, let's say, see some outputs that you want to use in the test. You can generate some data, extract data from a database. So you can use Excel or CSV files as mentioned here. So maybe you have a list of, let's say, college applicants if you're testing a university application and you want to make sure that you tested with 50. So you would open this Excel, CSV, import the data that you need. So all of these are processes that you can do ahead of time and promote static testing. So you're not really using them at the moment. You're just prepping ahead of time and making sure that whatever you take within that range is still relevant, it's maintainable, it's consistent, and of course, it's easy to determine when you run the tests. All right. Do you have any questions regarding the data management? I see Susan is typing. I'll give a bit of time. We will learn how to generate data. We do have some for some of the courses related to SQL in this, so you will see some instances where you can fetch data. We will also mention how to generate and create data in some of the lectures related to Selenium, because we will definitely need some kind of data to run those. So we'll have this covered in one way, in some way. Yeah. All right. Okay. Then if there are no other questions, I will let you, Jumana, take over and we can do the break for now.
Okay, awesome.
All right. Thank you, Jumana. I have to say I was in the lead for so long, but at the end, there will come another day. Maybe the next time my duck will be the winner. Okay. So, welcome back, everyone. So this next bit, we're going to be starting with a group activity, which is reviewing test cases. So what is the idea of the activity? So this is the scenario. Imagine a new client has walked into the door and they hand off their current test cases for their e-commerce site found here. So you have a link that let me just try to navigate here. So you can use these credentials to log in. You will see some. I can also show you the application itself here. Let me just do this. And you will see this site right here. So the cases are related to this. Now, what is the activity? In small groups, you have one person that goes through the test cases while everyone observes. So you will be divided into 3 groups, and somebody who wishes to and who you decide to can take over navigating through the test cases and simulating the steps that I mentioned. And as a group, you would need to note any flaws or areas that are not covered by the test cases. So anything that you find that maybe could be added to the test case itself, maybe some improvements. So think outside the box as well. That is very much encouraged. With the end goal being that you want to walk away with an improved test strategy and present it to the client. So um, that is the idea. So you will be divided into 3 breakout groups. You have test case 1, which is customer shopping flow, test case 2, validate text fields, and test case 3, shipping details form. So these are the 3 groups. And I can give you just a small example of what is needed. And then together, when we combine all the efforts, when we come back to the main Zoom meeting, we will essentially just see some different perspectives. So what each group has decided to underline that is missing, what can be improved. So this is all based on, of course, your, let's say, in a way, analysis of each test case. Do you have any questions about this exercise? If not, I'll just briefly just read through test case 1. So just to give you one more clarification. So here is the idea. You have these steps: log into the eShop with the credentials provided, add any item to the shopping cart and verify it shows up in the shopping list. Click proceed to checkout, fill out shipping details form, click submit order, confirm order details. Now what you can do, so somebody is going through these steps, you click them on the website here, and then you think about it and then say, I have a hint here. Ideally, the purchase patterns could be randomized so that the same scenario isn't being tested every time. So you, for example, say, okay, we're actually using the same data. We don't want to use the one scenario over and over again. So we want to maybe do a modification in which we add different sets of data. So that is the idea of this exercise. So you have a test case, you decide somebody to go through it, and then together you say, what can you add, what can you modify, what issues do you see that can limit the test case itself, how can you enrich it, and that's about it. If you don't have any questions, Jumana, you can create the breakout groups. And I say we meet back in about 10 minutes, so you have time to click about the page and then just also write down some improvements.
Folks, you should be able to click on join. You already have an assigned room. Seraphim and Angelo, you are free to move around the rooms when you feel suitable.
I'll move up to one of the groups. Seraphim is in the 1, so I can go to the 3.
I'll go to 2.
Yeah, finally, good.
Oh, I'm sorry.
Wonderful. Okay, so welcome back, everyone. Hope you had a good time and a nice discussion regarding all of these test cases. So now what I would like us to do is from each group, it could be anyone who was taking or writing down notes, you can write in the live chat and write for which test case you were working on. What were the things that you found were in a way missing? How did you, what ways did you found to improve the test cases given? Were there any additional issues and improvements that you yourself had regarding the test case? So it doesn't necessarily have to be all findings written in detail. It can be bullet points. You can just write some of them in detail. So however you want, you can add them in the chat and we can briefly go through some of them in correlation to the test cases themselves. So take your time. And again, if you have too many findings, you don't need to like send each and every one in detail. You can put some of them. All right, we see Jumana wrote the first one. Okay.
I'm writing it on behalf of
Yeah.
test group 2.
Great. We see Jordan added the test case 3 notes. Wonderful. Right. I'll start in the meantime, and then when we have something from the first one, we will see something related to that. So, for test case 2, we have the following: home contact logout have different format, colors, and fonts. So this is a first catch. Actually, maybe it's better if I put it here so you can see the findings better. I'll just increase the size of the chat. Let me just do this. And do it like so. There we go. So here are the findings. Shopping cart is in the middle, not on the top. When you scroll down, the options on the left sidebar do not appear. Bottom page, we think due to the image size, two products are next to each other, not under each other, and did not test the left bar. So when we go into the test case 2, we see that we want to validate the text fields, and we only have login to eShop with the credentials, confirm top bar text is present, confirm page header is present, confirm chart headers are present, confirm total text is present, confirm product is present, and then we have the number of fields. Whereas when we compare to what the analysis says, we have for these fields, we have different format, colors, and fonts. We have the shopping cart being in the middle top. When you scroll down, the options on the left side bar do not appear. So we see that there were additional scenarios that were not mentioned in this test case too. So when you're validating, let's say the text fields, you're not only focusing on just going and saying, okay, this is a text field, I can input something and everything is good to go. You need to look at the bigger picture. Now we see by you providing this analysis and this in-depth and thorough investigation of the test cases and the scenarios, you actually enrich this test case and have a bigger coverage, meaning that when you move to production, you won't actually have these issues that are written here present, since you will already have them noted and somebody would get on it. Very well done for group 2. Let's go for the test case number 3. So we have the test case number 3, which is shipping details form. For this one, we essentially log into the eShop with credentials provided, click proceed to checkout, fill out the following form fields, click submit, and confirm shipping details. Now here, what group 3 had is it doesn't notify cart is empty. So we're essentially trying to fill out the shipping details form, but we're not selecting a product. So we don't get any notification despite doing this. It doesn't ask for payment info, name, non-personal details. So if we want to test the shipping, we obviously need to do some kind of payment. Back button does not go back to checkout, can enter any value in any box. Phone number takes special characters. It should only take numeric. So we can see that there's so little coverage in this test case number 3 that just by adding all of these, we still have even more to add to the test case itself. And this is barely scratching the surface. So again, with going through the test cases, through the steps themselves on the page, the group was able to enrich this test case and to add valuable scenarios that whenever a user would go, and if they're not covered, it will be a big impact, negative impact actually on the application itself. So really well done test case for the test case 3 group. And do we have anything? We have cannot go back home, nor no country. Yes, wonderful. So these are all in addition to that. And let's see. And then I see this is from Francesco. I assume this is from the first test case. We can go to some of this. Phone number could be auto geolocalized too, based on the location of the user, like auto pre-filled, apart of course, to accept only numbers and no letters and everything. Okay, this is actually a pretty interesting and specific information. So I mean, I personally wouldn't have thought of this. And this was is related to customer shopping flow. Log into eShop with the credential provided. Add any item to the shopping cart. Verify if it shows up in the shopping list. Click proceed. Fill out shipping details form. Click submit. Confirm more details. So we can see scenarios that are so specific like this are actually very welcomed. So even at times, even if they are, let's say, edge cases in a way, they do provide valid input and have more coverage and save us a lot of time, since we won't need to think about them when we would provide the dynamic testing. Okay, wonderful job to everyone. I see all of the groups did super well, and I really like that you were all very much engaged in this exercise. So do you have any questions before we move on to the next section?
No, all good.
Okay. Right, then let's move on to static analysis and static analysis tools. Just to make sure you're, yeah, the screen, okay, shared. I thought it was not for a moment. So what is static analysis? So it's something that happens frequently, that people kind of think that static analysis and static testing are both the same thing. They are not, but you could count static analysis as part of the static testing process, and that's not incorrect in any way. The idea of static analysis is to have an automated checking of source code without executing the code itself. So what does that mean? That means that you take bits of code, and this is not really only meant for development code, so not only for the developer side, but it's also for the QAs that are making automation scripts. So what you're essentially doing is using a tool in a way like a grammar check tool in Word, for example. And what you do is go through the code using that automated tool, and it gives you some information, whether you might have some poor syntax, whether you have some deprecated variables, methods that you're using, or overall if you're not, if some coding patterns are not, let's say, optimal for what you're trying to do. So that is the idea of static analysis. So it's ultimately checking the code itself before it is executed. And I would refer back to one of the questions. This is the way that you can do static testing automatically. So again, it's not only tied to developer code, it is also used for automation scripting code. One additional thing that we will mention here, and I very and highly encourage that you remember this term, shift left testing. What is shift left testing? So this is something that very much promotes static analysis and static testing, and here's why. So when you have a development lifecycle, you have like a line, and the idea is everything goes from the left to the right. So the idea is you want to start testing as soon as possible, so as early as possible. So moving from the right to the left, hence the shift left in the name. And why does this static analysis process promote shift left testing? Well, essentially, when you create the code, before you even run and execute anything, you make sure that everything within that code makes sense. You make sure that there are no underlying defects. You make sure that the structure is good. You find that the clean code principles are followed. This goes for tests as well. So you actually try to check everything even before it's deployed. So it's on the left side of the deployment when you think about it. This also applies to other static testing, static testing practices, which we will see in a few minutes. So that is the idea behind this shift left testing concept. Now, before we move on, we have a short exercise here, which I want us to cover. So we have one question. I think it's pretty straightforward. So which option best describes the difference between static testing and static analysis? So you have four options. Again, 1 to 4, A to D, whichever you prefer. Okay, we have Valentina's answer. So we have already 4 people deciding on option number 3 or C. Okay. All right. I already see the vast majority leaning towards C. Okay, great. And I would definitely agree with you. The correct option is C, which means static testing being process of manually reviewing code documentation, the keyword here, reviewing, and static analysis is automated tools for scanning issues in code. Wonderful. Do you have any questions so far? See. The right to left. Okay. Let me try to put it. So the software development lifecycle, right? The idea is you have some kind of phase from which you create something and then you want to put it up and deploy it on production for users. So the development lifecycle is the process of creating an application. So what does shift left mean and what is the left to right? So imagine it like this. You have a line. So this is like, let's say one line. And this line is the software development lifecycle. What you want to do is you want to start at one point, finish at the end. The development cycle starts from left to right. That's the idea. And for what shift left testing promotes is that you should start testing practices. So you should do any testing as left as possible. So you want to move testing activities to the left, meaning to the beginning. So the left is the beginning, and what you want to do is do testing as early as possible. So that's shift left. So you're actually moving the activities to the left. Yeah. Okay, wonderful. All right. Okay. If there are no any questions for now, I will move on to lint tools. So now lint tools. I don't know if you have heard of such tools. If you have done some programming, you might have come across these lint tools, but I think they're more present when you're working with projects. What are lint tools essentially? Lint tools are uh, code analysis tools which flag errors, bugs, stylistic errors, suspicious constructs. So this is essentially what I was referring to earlier to the grammar checker of code. So the idea with the lint tools is that you write your code, and before you deploy everything and let the tester have a go at it, you essentially recheck everything using these automated tools, going from syntax to logic. So how does this work? You run this command most often on where your code is located, and then what happens is this little feature goes through each line of code, sorry, and then it says, is there any excessive spacing between lines, values that are declared but never read, maybe some commands that are not optimal for usage, poor standards, poor case structure, so syntactical errors, and more. So essentially a grammar checker tool for code. Now, why is it good? It enforces code standards and makes the project easier to follow, update, and it even compiles faster in some cases on larger projects. I can confirm this since this is something that we currently use at my project, which is very large scale and cloud-based. And actually, we're all using this type of lint tool, which is rough for Python. And the idea is we all follow and use it so that we can make sure that both our tests, so integration tests, end-to-end tests, unit tests, and the development of the components is structured. And I have to admit, it very much helps when you deploy things to make that they are, let's say, efficient and they work optimally, meaning that due to the code structure, nothing is slowed down and so on and so forth. But this is more in detail for programming. So for now, let's just focus on what the tool does. Here's some other examples as well. We have PCLint for C++, PyLint also in Python. This is a default one. I would recommend, if you ever want to read about it, check rough. I will leave this in the chat later on if you want to read about it. JSLint, ACELint for JavaScript, SonarLint, and there are many more of these tools you can find. What are the pros? Obviously, it can check for many things that can be overlooked by human error. So syntax, spacing, typos, we already mentioned this. It enforces good code style guidelines, which are very important. And I can't stress this enough. Following clean code principles is a must, especially taking into consideration that one day you might not oversee this code anymore. So somebody who comes at your place needs to easily understand what was the goal when developing the feature. They're most often free or inexpensive and can be plugged in any integrated development environment. So as I mentioned, it's supported by many programming languages, so they do not have any, let's say, conflicts when you want to plug them into your solution. On the cons list, we have that they may flag things that aren't errors or false negatives. So there are scenarios where developers might intentionally leave out something that needs to exist, but it might be unused in most cases, only used in one case. But this most often could be the only solution that they had. So it could flag that it's only used once. It could be reused in another scenario, but they said, okay, this is the way that we have to do it. So it could show some of these things as errors. It also doesn't teach developers best practices because essentially it kind of shows them what they only need to do. So if you want to teach best practices, the best way is to go about, read some documentation and see what are some principles that you would need to follow moving forward. Otherwise, you would most often only rely on the tool, which is not ideal. Additionally, they only flag things without offering solutions, and this can eat out into productivity. So they're not something that gives you an example of what you could do, rather they just give you where the issue is. And sometimes this can lead to you having to develop the test case or the feature so many times that at one point you even try to question the amount of work and everything that was worth it. So they could be frustrating at times, I would say, but nevertheless, quite handy, especially for the development of code. Any questions before we move to the next section? Let's check every red underline just in case. Yeah, exactly. Yeah. Very, very good way of putting it. If there are no questions, I will move to the advanced static analysis tools. Now, one um, one thing to keep in mind is that while Lean tools are handy in their own regard, we have some more static analysis tools that are even more to be used in common. Um, some of them we will go through here. You will see an example as well. And the difference between them and Lean tools is that they have pattern-based simulation. They have quality and complexity metrics, best practice recommendations, support for multiple safety and security focused coding standards. So already going above and beyond the Lean tools, and out-of-the-box certification for use in development of safety critical application. So what is the idea with these advanced static analysis tools? We talked about the Lean tools going through the syntax and then maybe even going through some issues like methods that are not ever used. However, these advanced tools can find bugs within the code, duplicate code, security vulnerabilities. So they're basically similar, but on a higher level. So they cover more ground. And they not only enforce best practices, they actually do, in a way, a greater coverage because they could show potential and underlying issues that even we as testers could maybe sometimes not notice. Mostly relying on security, because for security you need some different type of testing, like penetration testing, and if this is not something that's often practiced, these types of tools are the best go at to find these without, of course, having such a team regularly. One such tool is SonarQube. You might have heard of it, might have not. Most often people that I've talked to do not use SonarQube. However, it is one of the most widely used advanced static scanning tools. Um, I would say it's quite handy, and it's from my personal experience, I've tried to play around with it on some my personal projects. It's very handy, especially for development. It's very easy to integrate it in CI/CD pipelines. And the thing about it is that you can get a lot of information regarding the code itself. So it's like a lint tool, but you even get some recommendations on patterns, security. So it's very handy. Here's also a list of some of the companies that use it. Some of the pros are that it detects issues early on. So as I mentioned, as opposed to lint tools, it can find underlying defects. It has support in many languages and provides code review capabilities, freeing up developer time and focus. So this is the, let's say, selling point of SonarQube, because you reduce the time you need to have these formal peer reviews. That's why I said it's common for these greater companies, because there you would have pull request reviews of such a large scale that somebody might have to go and manually check 700 lines of code in maybe 10 classes. And it's a lot of time, and it's not ideal to lose somebody's time to just go and correct somebody else's work. So using this in such an environment is ideal. On to the negative sides, it can be time consuming because, again, it needs to scan the code thoroughly. It has the potential to still have false positives. So again, the scenario where you might have a one-off that makes sure that a certain feature works, you don't want that to be reported as an issue. And there are better dedicated tools for security scanning, but I would mention on a smaller scale. For a large scale project, SonarQube is definitely a safe bet. There are also other tools like this, Coverty, Clang, Infrastatic Analyzer. You can, if you want, do a bit more reading on them. However, as I mentioned, these are mostly used on large scale products. On smaller, you can do you can do the most coverage with Lean tools, as well as save on time and money. Now, another very proficient, I would say, practice in static analysis is DevOps. So you might have heard this term, development operations. And essentially, what is DevOps? It could be seen as a separate position in projects. So there could be a DevOps engineer, it is called. And what it does, it is brings testing, development, and operations into one. So what is the idea? Instead of developers working separately and then testers working separately, so the code is deployed, let it go, then US tester tested, send the feedback. Everything is combined into a single spot. And DevOps does that using CI/CD pipelines. So you have, imagine a system where the code is pushed, so everything that the developers worked on. Then, when it is pushed, before it is deployed, the tests that we are working on related to that code are run against the code. So essentially, we are no longer just doing everything in isolation and telling the team, okay, this is not working afterwards. We're doing it at the time they're deploying this. So the tests are run against the code that developers push. And later, if everything is okay, the deployment goes through and everything is on the environment. Otherwise, if there is an issue, they're immediately informed. So we have very fast feedback for both developers and testers, which is very reliable when time management is concerned. It has reliable releases because the code will be thoroughly tested by the cases that we design and the scripts, obviously. It gives visible information about defects, so very good reports. And it promotes automation, meaning that, again, costs and time are reduced. However, this does not mean that DevOps removes the need for manual testing. I want to stress that manual testing is still needed, especially for exploratory testing later on. So while it does promote automation and everything, it serves more as a tool to essentially help everything merge into a single spot. So it's quite handy, actually. I see a question from Francesco. Are all the software that the company need to buy lens for Imagine? So it even more, I actually saw that Seraphim answered it right now. I believe my net is a bit laggy. Okay, I will come back to this if you have time before the break so we can complete the content for now. Next is shift left. We already discussed and touched briefly about this. We mentioned why it supports static analysis, and I would add, in addition to that, how it supports static testing. So we mentioned start to test as early as possible in development lifecycle. So what you can do, you can write test cases before development begins. Run static analysis tools. So you can use SonarQube, you can use Ruffin. Let's say if you want to use the Lint tool, depending on the project. You can also go through documentation, through software architecture. You can also do non-functional testing. So not in terms of going on the page and trying to use tools to see how many users it can hold up, but you can actually go through documentation and see what is the expected amount of users. You can note that. You can see if this is realistic. You can compare to other sites. So you can actually, in a way, see at which aspects the non-functional requirements would be met and what requirements might not be added so that you can have a direct input before the application is deployed and before this testing happens. Now, it's very important to note that shift left does not remove the need for further testing or dynamic testing. It supports it. So you essentially cover as much ground early on so that when the actual execution commences and you have the code deployed, you can test everything in regards to system integration. You essentially have a reduced amount of issues that you have to think about and scenarios that you would need to do, but you will still need to thoroughly test each aspect of the components and the system itself. So it doesn't remove the need for dynamic testing, it just supports it and makes life easier for QAs. Before I move on, do you have any questions? I don't see any. So briefly before we move to the break, we have the dynamic testing recap. So we discussed up until this point, mostly things related to what is static testing and analysis, but we cannot forget dynamic testing. So we already mentioned that dynamic testing is the testing done after the application's execution. So this includes integration, unit, system, acceptance, every type of testing. And in the next section after the break, we will actually see how do we actually interconnect dynamic and static testing. So we'll take a bit of a look into some of the methodologies that you're already familiar with and how those methodologies practice static and dynamic testing both. So that will be for that will be basically it for the next session. For now, Jumana, we can go for the Okay, I'm going to share my screen again. All right. Let me just check if everybody can see it. And okay, great. Now, we left off at discussing about how dynamic testing links to static testing in some types of testing that we've already covered. So we're going to start right off the bat, and I'm going to need some of your assistance here, and you can write in the chat. I will mention one. So previously, you already were introduced to white box testing. So this was the testing that is more related to the software's internal functionality. So it is more focused on going through bits of the code. This is where the structure is known. So types of testing that are covered by white box testing would include unit testing. And this is the, let's say, most common dynamic testing type that falls under this category. Now, the idea here is that for this type of testing, you can actually do static testing as well. So we already learned from some of the exercises that you can basically implement static testing on everything. So the same applies to white box testing as well. So now I would like to ask you before I move down, what are some static testing let's say, techniques or practices that you think would suit white box testing well? So what are some ideas? You can write them in the live chat. So um, what what can you do from a static testing aspect to validate something while performing a white box testing technique? Yes, white box testing is dynamic. That is correct. But that is the unit testing part. We can still perform static testing on it. All right, I see Stephen wrote unit testing. So this is a type of dynamic testing. So think like this. We mentioned that we are talking about the code structure in white box testing, right? So how can we statically test something for which that we know the internal code structure? Wonderful. Messinas wrote reviewing the code. Wonderful. That is correct. So one thing when we know the internal code structure is we can actually review it. So we can go through each line, each branch, each condition. That is one thing that we can implement. Wonderful. Any other ideas? I would also add inputs and outputs of code at its lowest level. So you can actually go into the code and you can see what are some inputs and outputs. Do you think that these are the correct ones based on requirements? So you can match it with that. You can also try to see unnecessary or broken code paths. You can see some statements and loops, as we mentioned earlier, and you can see gaps in application security if you're more versed in that area, of course. So you can actually basically, as Ina said, reviewing the code. So, but just by doing this, you're performing static testing using a white box approach. So white box, while it is, of course, as Valentina mentioned, dynamic, that is true, you can still perform static testing on it. One of the examples is reviewing the code. Now, another way, which is, I would say, a bit less familiar to the majority of QAs, even with experience, is code coverage. There are such tools known as code coverage tools, which what they do is you create your unit test, let's say, that you will use in the code. And after you perform them, so after you execute them, or even before you can do this, you can see that you have a metric and it states that you have how many lines that you've. So we can actually use the graph to explain. So this is what you get as an output. See how many lines, how many conditions are covered. So the coverage idea is that this tool goes through the code, goes through the unit test, goes through the code itself, and it sees how much coverage do you have. So do you have all of the lines that need to be covered included? And then you can see, okay, maybe I have too few lines. Like here we see in the example, we have about 6 lines covered here out of 70. So maybe there is something in addition to that that could be added here in the unit test as well. Maybe where we have 2933 is too much. Maybe we do not need these amounts of lines to be covered from the code. Then for the conditionals, here we see we only have 4 out of 380 conditionals covered. So it gives us an indication that, okay, here we might need to work a bit on that. We have so many conditions, they're not covered. So we need to go through those and see which one makes sense to be covered, which one does not. So essentially, you're just making sure that the unit tests themselves have a good coverage, because at the end of the day, the point of the unit test is to cover as much as possible as with any other test and cover relevant scenarios. So this is just another way of using static testing and basically static analysis, because again, this is more related to the code structure itself. So it's an automated tool to check the code, similar to the lin tools and the advanced static analysis tools. So basically the idea is you can statically test using a white box technique. Do you have any questions regarding this? Wonderful. Thank you for that addition, Seraphim. Okay, if no other questions, I will just move briefly to this small exercise. So which of the following is an example of white box testing? This is just to remind ourselves of the dynamic aspects of it. I already see people writing A. Wonderful. Unit testing A. So all of you so far are going for the first option, which is nice. I'm just going to select it. We can check that. So we see that I'm going to do the second check as well. So the first one is correct. So it is unit testing. We already mentioned it a couple of times. Now, when we move down, we have one more question, which is what would not be covered by code coverage tools? So we already mentioned what the coverage tools are. We have a few options here. So what do you think will not be covered by code coverage tools? As you already, Francesco wrote C. We have people writing down C as well. Okay. Security vulnerabilities, C. Again, a majority of people are voting for the same option. All right. I would agree with you. I would go for security as well. We say that it is the correct one. So the coverage covers functions, lines, conditionals. So these aspects of the code itself, not security vulnerability. So it's not connected to actually checking some patterns and similar, since that is more the lin tools and the advanced analysis tools. So very well done. You all got the correct answer for both questions. So I'm very happy to see this as a result. All right, let's move on to black box. Now, for black box, we know that this is a type of testing technique where we do not know anything about the internal structure. We know that we have some kind of input and we have an expected output. So we know what is the input and the result, and we do not know the internal logic. So hence the name black box. So we do not know what's within it. So the idea here is that while again, this is more or less dynamic testing, and this is more or less the standard way of testing, where you would get some kind of, let's say, ticket for let's say testing a login flow. You understand what you need to put as input for the login flow. You know what you can expect at the end of it. So what is the outcome? What is the result? However, you are not very familiar with what is the structure and the code that's behind it, so how it is running, so that you can perform the flow. So that is in a way dynamic testing, since you're executing those scenarios. However, similar to the first section here, I would like to ask you for ideas. So what are some static testing techniques that you can do in regards to black box testing? So you can even use the example of the login flow. What static testing approach would you use here? So I see input output. So Valentina wrote, I'm confused. Are we talking about dynamic or static testing now? Module 14. We're talking about the correlation to both. So how static and dynamic testing can be used together under these test techniques. Exploratory testing, that is still a type of dynamic testing. So let me try to simplify it. So a black box testing technique, which is dynamic, is me trying to check a login form, right? I know what the input is, I know the output, and I don't know how the code works. So that is black box. Now, we know that me testing this and executing the scenarios is dynamic, right? Well, what will be the static approach to this scenario? So how can I statically test the login scenario? You were doing it previously in the exercise. So I see non-functional. That's still a type of dynamic testing. How about, let's say, how about the requirements? So obviously, if I do black box testing, exactly, Valentina. So check documentation. Exactly. I can go through the documentation. Maybe I will find something that does not make sense. Maybe I will find some requirements that the developers have now implemented. So definitely checking the documentation. Another example could be test cases. I can go through my test cases and I can say, hold on a second, I have never mentioned such a scenario and it had happened. So you can actually go through test cases for what you're going to test dynamically. You can go through the test plan, test scenarios. Wonderful, Jixing. Yeah, that's correct. So reviewing the documentation, the architecture, which we mentioned earlier, the diagrams, the test cases, scenarios, the test plan, all fall under the category of black box testing in itself. Because again, what was black box testing? Dynamic tested types, which we don't know the code, we know the input and the output. So basically a standard way of testing for QAs. And statically, it can be tested with review of requirements, documentation, testing plans, so on and so forth. So that is the idea behind it. We can see some examples here. So creating test plans, determining test coverage, deciding on appropriate test technique, evaluating test data to cover both positive and negative scenarios. So everything that you can test and you have a documentation about for that testing, you can review and essentially cover the static aspects of it. Now, what I will add in addition to this is that uh, when you perform black box testing, you do both functional and non-functional testing. Static testing can actually cover both. Now, this may be, let's say, more simpler to understand for functional testing requirements. For example, as the login flow that I mentioned, we can see the expected input and output data. So we can, let's say, create a vast amount of usernames and passwords. So you can do test data management, which we prepared with static testing. So we go into our database or whatever the service is for storing these accounts, and we can generate these users. Boundary values, so you can write down what values you would want to use for some specific edge case scenarios or scenarios in general. Equivalence partitions, data tables, so you can do all of these for the functional testing regarding black box. The other thing that is not so characteristic is that you can also do non-functional testing requirements with static testing. And how can you do that? Well, you can take metrics like peak load, stress test, and endurance metrics. So you can go through each of them, analyze them, compare them maybe to some previous iteration, to other pages, and just see how your environment can handle them. So you can prepare these types of information beforehand. You do not really need the application to be done to write down the metrics, user experience, and device requirements. So even before something is developed and updated for release, you can write down that you're expecting for the page to have fast response time, for let's say the search functionality to provide us with search results as soon as possible and not having to wait for 15 seconds. Common security threats, this can also be written down statically in a planning phase or just part of test cases. So you could implement static testing on both functional and non-functional types of testing within black box techniques. Do you have any questions for now? If not, we have, I think this is the last exercise that we will have. So we have this is like a set of activities. So I'm just gonna scroll down. Oh, we don't have an answer, great. So which of the following are examples of black box testing? Select all that apply. You can write multiple options here. So you can write 1, 2, let's check how many there are actually. 1, 2, 3, 4, 5, 6, 8. So 1 to 8 and A, B, C, D, E, F, G, H. A, B, G, I. H, yeah, A to H. I don't know, I forgot the alphabet for a moment. So yeah, you can write them in the live chat. I'll just scroll up a bit so you can see the options better like this. There we go. So which are examples of black box testing? Try to recall back on some of the previous lectures. You might have noticed some of these examples. And don't worry, it's perfectly fine at this point to even have some wrong answers. Again, this is part of the practice. This is part of the learning curve. So we learn based uh, on the amount of work that we put in. So 1, 2, 3, 5. Okay. I already see some answers coming through as well. People are typing in the live chat. Don't be shy. Again, there is no issue, even if the answers are not all correct. Again, it's to the idea is to kind of get you to do a bit more critical thinking and just overall see the how others also approach this. Um, software development engineering test is the SDET. So I don't remember what SDET stands for, Valentin. It's software development test. It's a QA basically. I see A, B, E, H, A, B, D, E, H. Okay, I see some variation already. Sorry, I'm gonna adjust my microphone. Software development, engineer, and test. Hopefully it's good now. So SDT is software development engineer and test. All right, so I already have a few options here because I see some other people are typing. I'm gonna evaluate some of those answers as well. So the most common I saw is the following, if I'm not mistaken. So I'm gonna just check them in total. So let's see. So from the answers that we have, we see that the black box testing techniques include test cases for numeric input field need to be created, test cases need to be written to check the navigation bar items and the UI display properly, and SDT searches the web for open source data libraries to import into automated test, and SD works with Teams product owner to determine what average peak application might be. Now, why are the others not the options? So you have API test cases are
Sorry,
discussed in planning.
no, sorry to
Yeah, sorry.
interrupt you. Can you please, yes, thank you.
It's okay now?
Yeah, can you talk for longer? Maybe we'll see. Okay, how goes?
Yeah, yeah, I'm talking now. I'm giving the example here. Hopefully it's right. Okay.
Thank you.
Yeah. Wonderful. No worries. Sorry for the mic issues. Yeah. So essentially, uh, this one immediately drops off because an imported library within developer code has known security vulnerabilities. This requires us to know the code. So it definitely is not a black box technique. API test cases are discussed in a planning meeting. So we're essentially not testing anything. This is just a planning meeting. This is a testing. This, in a way, a review as well. So here we're not really into the black box aspect yet. Static analysis reveals a switch case with an incomplete path. So this is again related to the code structure. You see, static analysis reveals a switch case with an incomplete path. So there's something regarding a path in the code. So it's a no-go. And then creating a test to determine whether a date function is outputting the correct date format. So again, this might sound like a black box testing technique, um, but the idea here is that we're focusing on a function. So if we're working with the function, we obviously have an idea of how it is working. So the idea of black box is to work on something for which we have little to no knowledge about, and then we can only have the input and the output. We know what's happening, but we don't know how the function operates. It is a bit tricky. It sounds like it's something that we do not know about, but actually the function, the code is known to us. So it falls off and it goes into the uh, more the white box aspect of it. So yeah, that is the idea. Still pretty good job. You got some of them correct. It is a more tricky exercise. However, again, we're here to even learn from such scenarios. So good job for nailing those that were correct. Okay. Why is not one correct? I see a question from Jordan Floyd. So why is not number one correct? Let me just go back briefly. So creating a test to determine whether a date function is outputting the correct date format. So you have a date function. You actually know how this function works. You have knowledge. So it's not something that you're trying to see how it will work out. It's actually something that you basically have an idea or see how it works. And you're trying to see if you do something, how it will respond based on your knowledge. So um, that is the idea behind it. What about 7? Let me check the 7 one. I think that's the last one. 3, 4, 5, 6. No, this one. An imported library within the developer code has known security vulnerabilities. Now, this one is not correct because it's related to the code. So this is more related to white box testing if you want to look at it that way, because an imported library within the developer code is stated here. So you know that if you add this, you will have some security vulnerabilities. That's why this is more or less related to white box testing instead of the black box technique. Yeah. I don't know how much. Um, yeah. So Jordan, to return back to your question, uh, you only just to put it as simple as possible in black box, if we know about the code and how functions operate, then it will already be not be black box testing. It will be in a way gray box because we know what are the inputs and outputs, and we also have insight into the code itself, so we know the function. So that's why it will fall off. Um, so that's a good explanation as well from Francesco. Thank you. Yeah. Oh, okay. I see. I see the confusion. For the time being, I'm gonna move next to the gray box testing section so we could meet also the later part of the requirements. And Seraphim, you will feel free to reply to the remaining questions if I miss some things. So gray box testing. Finally, we come to gray box testing. And as we all know by now, it is a combination of white box and black box testing together. The idea here for this type of testing is that we do not actually have a specific methodology that is gray box testing. It's both combined. Therefore, there is not a strict static testing approach to gray box testing. The way it works is you dynamically and statically test black box aspects and then white box aspects and combine them. So what do I mean by that? Well, let's say you have this warehouse inventory system. Now, the system has an extensive interface, many possible user paths and scenarios. It is pulling data from many sources, each susceptible to failure or security breaches. And if you were to focus on only white box testing, you will probably do a pretty good job at code coverage, but not so well in the entirety of the application. So how the API handles calls, maybe even some user interface issues could occur that you will not cover because you've only used white box testing. And then if you only do black box, you will overlook some third-party paths which might be vulnerable, so some security threats. And therefore, the ideal way to go about this is do both white box and black box static testing. Now, how you can use white box in this scenario is make sure that API contracts are set up properly to communicate with each other. So this is done via the code. Functional test plans created for any database or microservice calls. So you need to note down what are those microservice calls, the databases, and then see whether the calls that are going through with the applications are working as expected. And then static analysis tools on development and test automation side. So this is what I mentioned earlier, since this is a large scale product, having tools like lint and advanced analysis tools, you can actually go through the code while it's being after it is being developed, as well as the automation test script, since again a lot of coverage is done, and they can basically automatically check for vulnerabilities, issues with the code, bugs that may come out of the development side. So essentially have this as part of the white box static testing. For the black box static testing aspect of it, you can actually try system input and output analysis, both positive and negative scenarios, then end-to-end use case test scenarios, which are obvious when working with such a large scale application, and performance test planning and design. So we can see the black box static testing techniques are more or less the ones that are the most used. So end-to-end test, performance test, input-output analysis as well. So just covering these as well by going through the requirements, writing down the scenarios for the end-to-end test, writing down metrics for the performance, will have both static and dynamic coverage. Hence, combining them, we will have the entire static and dynamic test techniques that we will use for the gray box approach. Again, this is mostly used in large-scale applications, so this is not something that you usually do when you're working with more simple software. Do you have any questions regarding this area? I know it's a bit maybe tricky and it could confuse a bit, but if you have any questions. I see. Um, okay, I see Francesco wrote end-to-end use case test scenarios. Can you explain a bit more in detail what it means, just to clarify? Of course. So what does end-to-end mean? End-to-end means that you are testing the entire flow of a specific feature. So what do I mean by that? Let's take the e-commerce page that we had previously. So an end-to-end test would be the following. You start and log in with the valid credentials. You select an item from the search results used, so something that you wish to buy. You select the proceed to checkout CTA. In proceed to checkout, you enter the information needed for shipment, for payment, so every bit of detail. You go to the process payment site, you enter the card, so everything that you need to pay, and then you receive a success message, maybe even an email, depending on the flow. So the end-to-end test is actually this entire flow. So you're starting from point A, which is logging in, and end where you get the successful confirmation of the payment. It can also be a negative scenario, a negative end-to-end scenario where you try to pay and you get that a message that the transaction failed. So that's the negative side end-to-end scenario. So the idea is you start from the first bit of a component that starts an entire flow and finish at the end. That is why the name is end-to-end. So it's kind of like start at the beginning, do the entire flow, finish at the end point. Exactly. Yeah. Yeah. Exactly as you phrased it. Yeah, Stephen. So end-to-end is not the same as system testing. Yeah. And it is an entire flow. So an end-to-end test is not like uh, it is not the entire application that you're trying to test. It is entire flow from the application, and you can have multiple of those. So yeah. I see one more question from Jixing. Static analysis tools on the development and test automation side. Could you offer an example for this one? Okay. Um, yeah, so static analysis tools, we mentioned some earlier. I could say the one that I am currently using is Rough. And this one is used both for development and test. So the developers use it to make sure essentially that it catches some issues that they might have used if they are following some patterns. And for example, we on our end as testers mostly use it for syntax, for structure, and for making sure that we do not have any empty methods or unused variables. So we don't really go into the details of whether we have bugs because we're not really developing something, whereas the developers also get the output if they might have a potential bug. So you could use the same tool as the developers. Essentially, it's just what you need to get as a result of it. Hopefully that explains it. Alrighty. Okay. I think that is basically it for the time being. I think we can now move to the Miro board to do a bit of a conclusion, and then we will do the Kahoot afterwards. So I will be sending the link for the Miro. Just give me a moment. So let me just copy the link here. Here. I see Valentina wrote, I call myself sick for the Kahoot. Yeah, don't worry about it. So this is just a knowledge check. So it's a bit more interactive. So it's not all of the time me just giving the examples. We will also do a bit of, let's say, interactive learning. So in the Miro, I'm just going to share it right here with you right now. You will,
I'm sorry, Angelo, if you don't
sorry.
mind, I just want to remind everyone what is the point of this mirror board, right? So, in addition to the fact that Angelo's going to take the time to reflect on what we have learned in this session through the review, think of the review as the base of your own personalized mind map. So, you can take this and build on it on your own. Whether you're a visual person, you can draw stuff. You're a person who would like to add more notes and information according to every single, for example, the review, there's different review types. You want to write a little bit more about every single review type. That's totally up to you. You can take this. This is like, I would say, the bones of a general mind map that you would personalize on your own. And then the reflection part is just for us to help make sure that all is good and also for you to take the time to reflect on what you've learned. So what topics did you like in today's lecture? What didn't? What is still confusing for you? Still need more help with? That is something, if you write there, make sure to mention your name so Sidafim can follow up with you after a lecture and support what you used to think of something and now you think completely different, and other key takeaways. Taking the time to reflect helps not only you to better understand what's going on, but you can always come back to it and see how you learned and how you developed and gained from this lecture. I hope this makes more sense now. And yeah, back to you, Angelo. Thank you.
Thank you. Very well explained, Jumana. All right, while you are populating the sticky notes here, I will be briefly doing a conclusion for today's lecture before we move to the mirror, everyone's favorite part. So what we talked about is static versus dynamic testing. We'll focus on static. We talked about reviews. So the synonym for static testing, we talked about the different types of reviews. So inspections, walkthrough, technical reviews, how they take part in the software development lifecycle, what are the most common ones. We also discussed the phases of a formal review, which is one of the more rare, let's say, the ones that are more rare occasions. However, one of the highest importance, the most complex ones, and how each phase in itself provides to the success of this review. And we also discussed some of the roles in such a review, which we came to understand that each role is not strictly assigned to a single person, rather that multiple roles can be assigned to one person, or they can divide it depending on the project. We also talked about types of static and dynamic testing. We discussed what are some static analysis tools that we can use, like lin tools, SonarQube. We discussed about DevOps approach, how it's combining testing and development and operations together helps static testing and supports shift left testing, so testing as early as possible. So from here, I would really like to encourage you to remember this shift left testing. It is actually something that you will definitely see, especially when you prepare for ISTQB, is something that is very important to practice. Also, we talked about black box, white box, and gray box testing, and how we can convert dynamic testing practices in those techniques to static testing. So how each correlates to one another. And of course, we talked about test data management. So quality, quantity. Mentioned these go hand in hand. So performing static techniques, static testing techniques on the data itself, preparing it, generating it, making sure it's relevant, making sure that it's consistent is all a part of static testing, and it definitely supports the entire software development lifecycle just by having everything prepared beforehand, so that we will save a lot on time and also on efficiency when it comes to testing the overall application. That will be all from the conclusion on my end. If there is there any question that you would like to ask for now? All right. Let me just check then the Kahoot. If there are no questions, you can still have a bit of time before I start the quiz. So let me just check the link here. All right. I'm gonna share. Here it is, the Kahoot. And now I'm going to share the link for the Kahoot. So just a moment. Here we go. You can join using the following link. Thank you, Jumana, for also providing it. You have the pin here displayed on the screen. So you can all join. And once we're here, we will start with the quiz. Again, no need to be afraid of the Kahoot. So it's a way of learning. We see what are some of our strengths, what are some of our weaknesses. I will also guide you through some of the concepts that are where we have some incorrect questions, see what are the differences. So don't be afraid. I mean, it's one of the more, let's say, interactive and encouraging ways to improve ourselves. So don't take it so how should I say it, too hard. Okay. I see people are still joining. I'll wait a few more seconds to see if we're all here. All right. Okay. In the IC16. Okay. Wonderful. All right. So I think that we can start with the Kahoot. I wish you all the best of luck, and let's go through this. All right. Let's see the first question. Which of the following cannot be examined by static testing? I see the answers coming through. All right, I see all of you, mostly all of you, used encrypted code, and that is correct. It is a trick question. The thing is, it's encrypted code. If it's only code, it could be examined. However, it's encrypted. So even if we wanted to examine this, it's encrypted. We don't have any access to it, and that's why this is the correct answer. So sometimes static testing, unfortunately, cannot really be used on things that are in a way denied access to due to security reasons. All of the others fall into the static testing category. So really well done. I mean, I don't see what was the worry about the Kahoot. Let's move on to question 2. All right. Which participant ensures review meetings run effectively and everyone can voice their opinions freely? I see a lot of answers being submitted before the end. That's pretty nice. All right. Nearly everybody selected the moderator, which is the correct answer. Can see how the review leader could be because the way it's spinning, the review leader is more or less connected.
Angela, is it my internet? Serafin, can you move if it's...
To
I think it's only with his internet connection, I
Yeah, I
guess.
think it's
Because,
Angela's internet connection.
yeah.
Okay, sorry about that, folks. Yes, I believe he is having
okay,
internet
let
issues,
me just do
and I
this.
think he's back. Are you, Angela?
Is it okay right now?
We
Okay.
currently, yes, you're back. We currently can
Okay, great.
see the screen that the moderator is the correct answer, and that 10
Yeah,
people chose 10. Yep.
yeah.
I
Okay,
think you need
great.
to just reconnect now. Perfect. Thank you.
Yeah. Okay. Yeah. So can you see the Kahoot right now? Everybody
Yes.
else?
Yes.
Okay. Okay. Yeah. So that's what I meant. The idea was review leader is outside the review, so just preparing the people and the participants that need to take part, as well as the materials that will be tackled. I see people cannot reconnect to the Kahoot. Okay. So just a moment. Should I restart the Kahoot in this
Maybe I
case?
think that makes the
Okay.
most sense, if that's okay.
Okay. Okay. Yep. Yep. No worries. Let me just do this. Leave. Okay, I'm gonna try to do it again. Go here. Okay, then we'll just save on time with the questions that we answered, so you already know the answers to those. So let me try to get us in as fast as possible. Static dynamic testing. Okay, you can use the pin that will be generated right in this second. Yeah, there we go. Sorry about the issues on my end. I don't know why my connection dropped, so I connected to the other router, which is working, and the other is not. So I have never experienced this before, so I'll try to make sure it's okay for next time. Okay, I see 9 people in. We need 5 more from now. Okay, I don't see anybody else still joining. I'm going to continue so that we can finish the questions and we can move on to the final part of the lecture. Great, Samson joined. So I'm gonna click start and we can just, if it's the same questions, we can just answer the correct answer and that's it. So let's go. Okay, which of the following is not a formal review phase? Wonderful, different question.
I do want to clarify, they're the same 10 questions, but different order. So you're going to
Yeah.
get these questions later on.
Yeah. Okay. All right, so we see that most of you chose, or actually it's balanced, okay? Execution, which was the correct one. And then we have kickoff. So which of the following is not a formal review phase? So kickoff is a phase. It is optional. That's definitely true. So that might get somebody off guard. However, it is still a phase of the formal review. It just doesn't mean it has to be followed. And execution is never mentioned. So this is just execution of test code. This can mean everything. So this is definitely not a formal review phase. Good job. Okay. Let's move on to the next question. We'll see the leaderboard. Which of the following is a factor that contributes to a successful review? Right? We didn't have this question as well, so. I would say this is maybe one of the most difficult questions from what I saw from the Miro. So, all right. Split large work products into smaller parts was the majority. Very well done. That is the correct one. As for the second, set review evaluation as an objective. This is a factor. However, it's not the main one that contributes to successful review. So when you split the work into smaller parts, it's a lot easier to kind of evaluate everything, get any necessary requirements reviewed. So essentially, this is the best way to contribute to the review and its success. Righto. Let's move to 3. Which of the following cannot be examined by static testing? I think that we went through this one, so I'm going to skip this question because you already got the answer earlier. So we're going to move to the next one. Which of the following is not a characteristic of high quality test data? Okay, let's see. So high quality. So most of you said randomness, which is correct. We never mentioned randomness when we're talking about characteristics. It is good to have different data, which is under the point of diversity. And then for consistency, it is a factor. So we want the data to be consistent. We do not want to have it to be all over the place, which is randomness in a way. So therefore, this is the correct response. Okay, let's move to number 5. Which of the following is a benefit of static testing? Okay. Great job. All right, that's amazing. So I see most of you chose this answer. And I mean, we mentioned this multiple times. Requirements early, testing early. That's the idea of static testing. I'm going to move to the next question. I think we have a few more. What is the main difference between static and dynamic testing? Okay, this was another phenomenal result. So you already got the gist of it. I'm very happy to see that you're already differentiating between these two concepts so well. Well done to everyone for this one. Fantastic job. Francesco in the lead from the leaderboards. And which of these review types is not matched with its correct objectives? I think I will do this as the final question, so we'll leave the others some time to finish the Zoom polls. Okay, so I see most of you answered the technical review, gaining consensus, brainstorming, and motivating authors. Well, technically, this is also is not correct. Inspection, generating new ideas and motivating authors to improve. So this is actually part of the technical review. So this needs to be the one that's matched to that. So therefore, this is not the correct answer. So still, it is a bit of a confusing question, and I want us to go through this one. I will now stop with the Kahoot because I want to give the floor to Juman and the others for the Zoom polls. I think we covered the main questions. We also have one that we can skip, and the two remaining ones are not that, let's say, of high importance. So thank you all for taking part in this. And from my side, that will be all. Juman.